Hello everyone. In this video, we would like to discuss the solutions for control systems questions given in recent TS GENCO 2024 exam. Now the question is, the open loop transfer function of a closed loop control system is k by s into s plus 4 into s square plus 4s plus 20. So what is the angle of departure at the pole minus 2 plus j4 is? Now for this system, suppose if you draw open loop pole 0 location, we will have, there is a pole at origin 0 and minus 4, and there is a complex pole located at minus 2 plus or minus j4, minus 2 plus or minus j4. So the question is, what is the angle of departure from the pole at minus 2 plus j4? So what you have to do here, now say for example there is a test point epsilon that is very close to minus 2 plus j4, and from this point to the pole the angle of contribution will be, let us say, theta 1, and you can project phasors from the different open loop poles to the test point, and let us give the angle names. This is a theta 2 and this angle is a theta 3 and this angle is theta 4. So now by applying angle of in order to find angle of departure, by applying angle criterion, you can find summation of all angle contributions from all open loop poles to the test point will be odd multiple of 180 degree. So as all are poles only, no zeros given in the question, therefore we can take minus theta 1, minus theta 2, minus theta 3, minus theta 4 is equal to 180 degree. So that minus theta 1 minus, now I can say this theta 2 is equal to 90 degree plus tan inverse opposite side by adjacent side, that is 2 by 4 minus theta 3 will be 90 degree, hence minus 90, minus tan inverse theta 4 opposite side by adjacent side, that will be 4 by 2 is equal to 180 degree. Now let us simplify this. This will give you minus theta 1 minus this 90 and 90 will be minus 180 degree, minus tan inverse 2 by 4 and minus tan inverse 4 by 2. We need not to use calculator, together it will give you minus 90 degree is equal to 180 degree. Therefore minus theta 1 is equal to 180 plus 270, 450 degree, which is same as 90 degree, and hence theta 1 will be is equal to minus 90 degree. Therefore answer will be option 1. Answer will be option 1. That is the correct answer. Now let us move to the next question. In which of the following cases a control system is not stable? Gain margin and phase margin are positive. These two conditions are for stable system. All poles are in the left hand side of S plane, that is also for stable system. Phase crossover frequency greater than gain crossover frequency, this is also for stable system. Whenever damping ratio is less than 0, the closed loop system poles will be in the right hand side of S plane, so that the transient response will keep on increases as time tends to infinity. Therefore, we can conclude damping ratio is less than 0 belongs to unstable system. Hence, for this question, answer will be, correct answer will be second option. Now, let us move to the next question. A system G of S, a system has G of S is equal to K by S into S plus 1. What is the value of K for the gain crossover frequency to be 10 radian per second? Now, for this particular transfer function, if you write down corresponding frequency domain expression, K by J omega into J omega plus 1 by replacing S with the J omega. Now, yet gain crossover frequency as per the definition, it is given 10 radian per second. At this frequency, magnitude of the transfer function is equal to 1 at gain crossover frequency. Therefore, K divided by magnitude omega GC under root omega GC square plus 1 is equal to 1. Therefore, this will give you K divided by 10 into root of 10 square means 100 plus 1. So, this will be approximately K into, K is equal to 10 into root 101. This is approximately 10, depends on the, 10 into 10 will give you 100. If you use calculator, you will get 100.5, so that it is approximately 100. Option 4 is matching with the correct answer. So, for this question, correct answer should be option 4. Next one, a system has open loop transfer function G of S is equal to S plus 2 divided by S plus 1 into S minus 1. The number of encirclements of Nyquist plot around -1 plus J0 R. So, if you follow my classroom course, the same problem we discussed in the class also. If you recollect from that, the Nyquist diagram for the given transfer function will be, I am drawing complete Nyquist diagram here. C1 mapping will be like this. This is a C1 mapping, and this magnitude will be 2 units, and hence -1 point will be inside this Nyquist plot. C2 mapping will be converted into origin and a C3 mapping will be like this. Therefore, with this you can easily identify that the number of encirclements of the Nyquist diagram with respect to -1 point will be once in counterclockwise direction. Hence, option 3 is the correct answer for the question. Next one, which of the following is not true? So, by seeing all these equations, in the first option itself you will get the answer. State space model of a system is unique. It is not correct, because for a given physical system, depends on the selection of the state variables, you can have multiple state space models. Even if you look into the remaining statements also, you will understand state space model is applicable for multi-input, multi-output, non-linear and time variant systems. That statement is true. Transfer function is applicable only for linear time invariant systems. This is also true. In state model, initial conditions are taken into consideration. Okay, we can take, or depends on the requirement, you can take it or not also. Therefore, based on the given options, we can select option 1 is the first correct answer. The next question is, the open loop transfer function of a unity feedback control system is G of S is equal to 30 divided by S into S plus 1 into S plus T, where T is a variable parameter. What is the condition for closed loop system to be stable? Now, from this, if you write down closed loop transfer function or characteristic equation will be S into S square plus Ts plus S plus T plus 30 is equal to 0. Hence, you can write S cube plus 1 plus T into S square plus Ts plus 30 is equal to 0. Now, by using this characteristic equation, if we define Routh's table, we will get it like this: S cube, the first element will be 1 and then T, S square element T plus 1 and here 30, S power 1 element T square plus T minus 30 divided by T plus 1. S power 0 element is 30. So, for closed loop system to be stable, what is the condition? For closed loop system to be stable, first column elements should be greater than 0 or positive number. Therefore, one condition will be T greater than minus 1, another condition will be T square plus T minus 30 should be greater than 0. So, if you find the roots for this, you will get it like T minus 5 into T plus 6 greater than 0. Suppose if you expand this, what will you get? T square plus 6T minus 5T will give you plus T minus 30 greater than 0. Hence, we can have a condition T greater than 5 or T greater than minus 6. If you take a common condition to satisfy all these cases, you will have a T greater than 5. That will be better option. No, it's the correct answer also. Okay. So, any number which is greater than minus 1 or minus 6 or 5 will be considered as a correct answers for the question. So, T greater than 5 will satisfy all these three conditions. Next one, another very simple question. The steady state error for the first order system shown in the figure below for unit ramp input. Unit ramp input means you need to find a steady state error by using a velocity error constant, that is a kV. So, in order to find kV, first let us look into open loop transfer function of the system. Okay. So, if you draw for what type of system this transfer function we will get, this is R of S and this is a C of S. Therefore, G of S will be 1 by Ts, and if you find C of S by R of S, then you will get 1 by Ts plus 1. Now, in this case, what will be kV? Because we want steady state error by taking unit ramp function. So, kV is equal to limit S tends to 0, S multiplied with G of S. So, this will give you 1 by T. Therefore, the steady state error with respect to this ramp function will be 1 by kV, and this is equal to simply capital T. So, option 1 is the correct answer for this. Next, there are two statements given. From these two statements, we need to identify what are the correct statements. phase lead compensation is used to increase rise time and decrease overshoot of the system. This is not correct, because lead compensation can improve transient stability property. Okay, so transient stability means the response, the speed of the response can be improved, and hence we can say that lead compensation property will be, it will reduce the rise time. So option or statement 1 is not correct answer for this. Phase lag compensation will improve the relative stability of the system. This is also not a correct statement. Okay, and hence in my opinion both the statements are not correct. Both the statements are not correct. So option 3 will be correct answer for this. Now let us look into the questions from power electronics. Okay, let us look into the questions from power electronics. So the first one, a single phase full bridge diode rectifier with a large output filter capacitance feeds a resistive load. The input current is, it is a straight simple theoretical question. If you have an idea of the waveform, you can say that this because of the capacitive load or capacitor at the load side, of course it is acting as a filter also. The source current will have a peaky nature, and it is not a pure sinusoidal distorted. Whenever the waveform has a distorted waveform, obviously its power factor will get reduced less than 1. Therefore the correct answer will be, the input current waveform is peaky in nature and distorted with the power factor less than 1. Third option. Now the theoretical statements. Identify the wrong statements from the following. IGBT is a voltage control device. It is a correct statement. Power MOSFET is current control device. This is not correct, because power MOSFET is voltage control device. Turn off time of an IGBT is less than that of power MOSFET. Turn off time of an IGBT, it is more. Why? Because the IGBT device was developed by introducing minority carrier injection in the power MOSFET. Because of the minority carrier injection, there is a charge stored in the device, and hence the device will take or exhibit more switching times comparing with the majority carrier device MOSFET, and hence second and third statements are not correct. IGBT has high input impedance, that is a correct statement. So option 2 will be the correct answer for this question. Next, in a DC to DC switch mode converters, of course just to confuse the student, it is mentioned DC to DC switch mode converters. These are general statements only. Which of the following statements are true? In the PWM switching at a constant switching frequency, the switching duty ratio is inversely proportional to amplitude of the control signal. This is not correct. It is not inversely proportional, it is a directly proportion. In control of converters, the switching frequency of the converter is same as the frequency of the repetitive waveform, which is a sawtooth waveform. This is correct. In a control of a converters, especially DC to DC converters or inverters, the switching frequency of the converter will be same as the sawtooth frequency, and the fundamental frequency of the output will be same as the frequency of the modulating signal. So this statement is correct. In the steady state operation of a converter, the integral of inductor voltage over one time period should be greater than 0. This is not correct. This should be 0. The average current through capacitor operating in a periodic steady state is 0. This is correct. Therefore, second and fourth statements are correct for the given question. Next question. MOSFETs are connected in parallel very easily because they will have positive temperature coefficient of resistance. Whoever is following my class, it's a very repetitive I used to tell this statement. Next one. A large amp hour capacity battery, a large ampere hour capacity battery of 120 volt is charged through a resistor 7 ohm via a single phase half wave uncontrolled rectifier single diode fed by the AC supply of 240 volt peak. So from the given data, I can quickly note down the points. Load side, a battery voltage of 120 volt and has a resistance of 7 ohm, and a supply side source voltage has a peak value of 240 volt, that is Vm. Next, source frequency is 50 hertz. Therefore, one cycle time, let me write it a capital T, is equal to 20 millisecond. Okay, one cycle time capital T is equal to 20 millisecond. Now, what is the question here? What is the peak inverse voltage of the diode? First, let us look into that. PIV rating in case of RE load is equal to E plus Vm. So this will give you 120 plus 240. This is equal to 360 volt. What is the circuit turn off time? So in a circuit turn off time is not appropriate word for in case of diode, but we can understand circuit turn off time will be the relevant question if the device is a SCR. But from the examiner point of view, we can understand that how much time the diode will be turned off, that we can understand. So if we just look into the waveform here, this is a source voltage and this is a load EMF E. So the diode will turn off from here to here. This is a off period. Okay. So from where to where this turn off period, that is now this point will be pi minus theta and this point will be 2 pi plus theta. In a simple words, we can say that turn off interval of a circuit will be pi plus 2 theta. Okay. So what is the pi here? Theta is a sine inverse E by Vm. Sine inverse load side E value is 120 volt, Vm value is 240 volt. Therefore, this is equal to 30 degree and pi value is 180 degree. Therefore, pi plus 2 theta will be 180 plus 2 into 30, 60 degree. This will be 240 degree. So 360 degree interval is equivalent of 20 millisecond. Okay. 360 degree interval is equivalent of 20 millisecond. Therefore, 240 degree interval will be equivalent of 13.33 millisecond, and hence third option will be the correct answer for the question. Now let us look into another question. This question is based on the buck boost converter. In fact, this is one previous gate question. It is a switch rate at 10 kilohertz. Current I is at the edge of continuous conduction. What is on time of the switch and peak current through the inductor? Now in this case, suppose when the switch is turned on, this is how inductive current will flow, that is, let us say I. When the switch is turned off, this current will, or energy stored in inductor will be released through this 500 volt source. Therefore, first let us write down basic equations here. When switch is on, when switch is on, L into di by dt is equal to 100 volt. In other words, di by dt is equal to 100 divided by L. Next, when switch is off, L into di by dt is equal to 500 volt, or di by dt is equal to 500 divided by L. So, from these two numbers, what we can understand, when a switch is turned on, the rate of change of inductor current is 100 by L. Okay, that means the rising slope of inductor current is 100 by L. When the switch is turned off, the decreasing slope of the inductor current will be minus 500 by L. Okay. Now, on this diagram, just for ease of understanding, that to reduce the difficulty, this diagram is also given. Suppose if I take this triangle ABC and this is a D. In triangle ABC, the slope can be defined as 100 by L is equal to BC divided by AC. Therefore, BC is equal to 100 by L multiplied with dt, where dt is the turn on time of the switch. Similarly, in triangle BCD, 500 by L is equal to BC divided by CD. Therefore, BC is equal to 500 by L into CD is nothing but 1 minus D into T. Now, by equating BC we will get 100 by L into dt, 100 by L into dt is equal to 500 by L into T minus dt, or 1 minus D into T, both are same. Now, by simplifying this, what we will get, dt is equal to, first you can cancel L on both sides, these two zeros cancel, then we will be remaining with the dt left side, right hand side is 5t minus 5 into dt. In other words, dt is equal to, 6 dt is equal to 5t, hence dt is equal to 5 by 6 into t. As the frequency is given 10 kilohertz, one cycle time will be 100 microsecond. dt is nothing but a turn on time of the switch. 5 by 6, 0.833 into 100 will give you 83.33 microsecond. That is a turn on time of the switch. Another question is, what is the peak current? Both are given. So, peak current is nothing but BC. So, BC is equal to 100 by L into dt, where 100 by L value is 100 microhenry given, dt value we got 83.33 micro. So, by simplifying you will get 83.33 amperes, and hence option 4 is the correct answer for the question. Now, the next question, this is from the drives chapter, but it's a very simple question. The 4-5 statements, lines are there, but without putting pen and paper, you can easily answer it. 228 volt, 40 ampere separately excited DC motor has a nominal speed of 1500 rpm and armature resistance of 0.2 ohm. If three-phase fully controlled rectifier is used to drive this machine, it is found that the motor operates at a rated torque and a rated speed at firing angle alpha is equal to 0 degree. If the load has linear characteristics with 0 torque at 0 speed, what is the angle alpha to reduce the speed to half the rated speed? Now, when the load has a linear characteristics, in order to reduce the speed by half, to reduce the speed to half the rated speed, what we should do? Vt should be reduced by half. Okay, Vt should be reduced by half. But as the motor is controlling from three-phase full converter, three-phase fully controlled rectifier, what is Vt? Vt expression is 3 Vml by pi into cos alpha. In order to reduce this 3 Vml by pi cos alpha to half value, alpha must be 60 degree. Okay, alpha must be 60 degree. Then only the terminal voltage of the rectifier circuit will reduce to half, and hence the speed will also reduce to half. That is a very simple question. Answer will be first option. Now the next question, this is also a straight question itself. A single phase full bridge inverter delivers power to series RLC load with the resistance 3 ohm, XL value 6 ohm, XC value 10 ohm. Source voltage and output frequency are given. Thyristors are considered as the switching devices, and then the switches are turned off by. Now here, if the load power factor is leading or lagging, accordingly commutation scheme will be decided. Okay. Suppose load, for the given case, load power factor is leading. How can I conclude this one? Because XC value is given XL from the data. XC is 10 ohm, XL is a 6 ohm. Hence, XC value is greater than XL. Hence, in case of leading power factor load, the scheme of commutation is load commutation. Scheme of commutation is a load commutation. In case of inductive load, that is, if it is given XL greater than XC, in that case you have to choose forced commutation. Of course, that is not the option here. Okay. So for this question, as the load is leading power factor, you should select load commutation. Next, of course, this is a question from HVDC converter. Let us cover in our discussion itself. The instantaneous DC link voltage when valve 1 and valve 2, here valve in the sense you just need to imagine SCR itself, are conducting, and the valve 3 is triggered in a 6 pulse HVDC converter with overlap angle greater than 0 will be. Okay. Now, what condition is given here? Valve 1 and 2 are already conducting. Okay. Now, say for example here, this is the condition given. Okay. Now, valve 1 and 2 are conducting. In this case, volume in the sense you have to consider only SCRs. Now, valve 3 is triggered. So, that is the point here. Okay, at this point. Now, overlap angle is given greater than 0. That, what do you mean by that? This is the overlap period, right? Therefore, in this interval, what are the conducting valves or what are the conducting devices? 1, 2, 3. 1, 2, 3. So, when 1, 2, 3 devices are in conduction, 1 is in the upper half, 3 also in the upper half, and 2 is in the lower half. In this case, you can write output voltage is equal to VAC plus VBC divided by 2. Of course, the question it is mentioned E, but I am more habituated to write V. So VAO minus VCO plus VBO minus VCO divided by 2. Now here VAO plus VBO, if you combine these two terms, you can write it as a minus VCO divided by 2. Therefore, it will give you minus 3 by 2 into VCO, where VCO is the phase voltage. In the data, it is given EC, and hence you can select option 4 is the correct answer. So with this, I can conclude my part. So from my contribution for this exam, control systems 8 questions came, power electronics 8 questions came, and even HVDC and facts also I only covered that. So HVDC one question. In fact, it is used the word HVDC, but strictly speaking, it is a 3-phase rectifier circuit. Okay, and even a syllabus is included facts, but facts questions are not given. With this, I will conclude. Thank you.